Hey guys, so we're going to learn lesson 7 today. It's talking about three-dimensional figures. So you will need to take notes during this video. You will need to upload your notes as a PDF, and then you'll need to complete the Schoology homework check. Hopefully now you're kind of in the routine of watching the video, taking notes, uploading your notes as a PDF, and doing the Schoology homework check. You'll do that for today's lesson. You'll do that for Thursday's lesson. Friday, we don't have any class because it's Good Friday. We'll continue that next week. You'll review next week as well, and you have a Chapter 7 test next Thursday, April 16th. Okay, so let's go ahead and get going with Lesson 7-4. All right, Lesson 7-4 starts on page 305, and today's date is the 8th, Wednesday the 8th. Okay, so we're talking about three-dimensional figures. What we've talked about so far is area, and we've talked about area of two-dimensional figures. So area of a rectangle, area of a triangle, area of a trapezoid, area of a parallelogram. Those are all two-dimensional figures, meaning that's one plane. We can draw that on a sheet of paper. We can draw a rectangle. We can draw a trapezoid. We can draw a triangle. Those are two-dimensional. Okay, we're talking about three-dimensional figures, meaning that it's like 3D. It has some more dimension to it. So a solid is a three-dimensional figure that encloses a space. A polyhedron is a solid whose faces are all polygons. So let's write down what a solid is. A solid is a three-dimensional figure. You've seen maybe 3D movies before. That's different than a 2D movie. A 2D movie is where it's flat on the screen. Okay, a 3D movie is where it pops out at you. So that's what it is. That's a two-dimensional figure. This here is a three-dimensional figure. It has dimension to it. It pops out at you. We'll talk more about that in a second. So a solid is a three-dimensional figure that encloses a space. So a solid, a three-dimensional figure that encloses a space. A polyhedron is a solid whose faces are all polygons. We'll talk about what faces are in a second. Whose faces are all polygons. Okay, we'll talk about three vocabulary words that we'll really mention a lot throughout the rest of this lesson: face, edge, and vertex. So let's write those down and then we'll talk more in real life what those actually look like. So face. A face is a flat surface of a polyhedron. A flat surface of a polyhedron. Okay, an edge is a line segment where two faces intersect. We'll get all of our notes down and then I'll talk about what they each mean in a real life example. And then a vertex. A vertex is a point where three or more edges intersect. Just put a point. A vertex is a point. All right, so now that you have those three definitions there, let's look at like this cube here and talk about how many different faces, edges, and vertex. These are made of magnetiles. If you have these at home to play with, you can build some three-dimensional figures as well. So here we're looking for faces, and a face is a flat surface. So this is one face, this is another face, this is another face, This is another face, and then these two would be different, another faces. So this cube would have 6 faces. 1, 2, 3, 4, 5, 6. All right, so if we wrote this cube out, if we drew this cube, so draw a square, 3 diagonal lines coming off of it, and then connect them. All right, then you can do the dotted lines behind it to show. Mine's not perfect, but it'll work. So a cube has 6 faces. Now, how many edges? The edge is the line segment where 2 faces intersect. So these 2 faces intersect right here. This is an edge. So we can count all of our edges. We have 1, 2, 3, 4, 5, 6, 7, 8, and then we'll have 4 more on this side. 9, 10, 11, 12. So I can count that again for you so you can see all the edges where all the faces meet. 1, 2, 3, 4, 5, 6, 7, 8, and then edges on the bottom side. 9, 10, 11, 12. So a cube has 6 faces, 12 edges, and then the vertex are the points. So let's count how many points it has, those corners. 1, 2, 3, 4, and then it's going to have 4 on the side. 5, 6, 7, 8. So then 8 vertex. Plural of vertex is vertices. So 6 faces, 12 edges, and 8 vertices. 12 edges and 8 vertices. So hopefully you see that in this example of a cube here. We can also look at another example if we have like a triangular prism. This is a triangular prism here. Let's find the number of faces, edges, and vertices of this solid figure here. So to draw this on your paper, you can draw a triangle, draw 2 lines coming off of it, like that. And then you can draw the dotted line to finish that triangle in the back, and then connect. We'll practice drawing these in a little bit. So this is called a triangular prism. We'll talk about naming them in a little bit as well. Actually, I believe next lesson we'll talk about naming them. So triangular prism. If we talk about how many faces this has, okay, so how many faces, how many flat sides? 1, 2, 3, 4, 5. Okay, so that has 5 faces. If we look at the drawing, you can see it has this one in the front, this one in the back, and then it has 3 going around it. This one on the slanted side, that one on that slanted side, and then the bottom one. So 5 faces. Let's talk about the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges. If we counted the edges here on our drawing, it would be 1 here, 1, 2, 3, 4, 5, 6, and then the 3 lines connecting them. 7, 8, 9. Okay, now vertices. The vertices are a vertex. The vertex is a point. Vertices, all the points. So let's count 1, 2, 3. I counted those 3. And then 4, 5, 6. That's all, 6. 6 vertices. On your drawing here, you can count them. 1, 2, 3, 4, 5, 6. All right, let's look at one that's just a drawing. so you can become comfortable with looking at it just as a drawing. What if we had this figure here? Okay, so hopefully you can kind of see that. Trapezoidal prism. We'll talk about the difference between prisms and pyramids after this example. So let's find out how many faces, edges, and vertices this has. Okay, so pause the video and see if you can figure that out on your own. Okay, so let's go ahead and look here at how many faces. So it has this one on the top, and it has a matching one like that on the bottom. So that's 2. Then how many does it have going around it? So 1, 2, and then around it has this one, 3, 4, 5, and then that big one in the back, 6. So hopefully you got 6 faces. Edges, let's go over the edges here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 edges. And then vertices, how many corners? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Okay, we've talked about, you've heard me say prisms, cube, triangular prism. This is an example of a pyramid. So let's talk about the difference between that. So here's the pyramid. This is a triangular pyramid. This is an example of a triangular prism. Do you see the difference between these two? This one is a pyramid and this one is a prism. So think about what the difference is. You should notice that a pyramid comes to a point. Think of the Egyptian pyramids, right? They all come to the point. Come to a point there. The prism has two matching bases. Triangle here, triangle here. So that's the difference between a triangular pyramid, has a triangle as a base, triangular pyramid, and a triangular prism. Let's write that down in our notes. So a prism is a polyhedron that has two parallel identical bases. Two parallel identical bases. That's what a prism is. Two parallel identical bases. Okay, the things that connect those two bases are parallelograms. Parallelogram here, and parallelogram here, connecting those. Two identical bases. This is a prism because it has two trapezoids as identical bases. Rather than a pyramid, think of the Egyptian pyramids. Envision those in your head. Okay, it has one base. The lateral faces on that are all triangles. So in prism, let's write lateral faces are parallelograms. Pyramid, one base, the lateral faces are triangles. So look at this pyramid here. It has one base, and all of the lateral faces are triangles, as you can see. So that's the difference between a pyramid and a prism. The shape of the base tells the name of the prism or the pyramid. So you name this triangular pyramid based on what its base is. Triangular pyramid. Triangular prism. This is a rectangular pyramid because its base would be a rectangle or a square. All right? So you name it based on its base. You name a prism or a pyramid based on its base, whatever its base is. So the shape of the base tells you the name of either one of those. That's why this was a trapezoidal prism. So let's write that in our notes just so you have that too. The shape of the base tells the name of the prism or pyramid. Okay. Now, to practice drawing solids, if you want to draw a rectangular prism, for example, so rectangular prism, just by the name it tells you important things. It tells you that its bases are rectangular, it's a prism, so it has two parallel and identical bases. So rectangular prism, you can draw two identical rectangles kind of offset from each other. All right, so draw two identical. Those are your two bases. And now just connect their matching vertices. So this bottom left one connects with this bottom left one. This top left connects with this top left. This bottom right connects with this bottom right. And this top right connects with that top right. So you can draw it like that. If you want to draw a triangular pyramid, now you could go back with your eraser and erase and make those hidden ones like dashed, but I'm okay just if you want to draw it like that too. If you want to draw a triangular pyramid, okay, triangular pyramid. So that means the triangle is your base, a triangle is your base, and it's a pyramid. It comes up to a point. So draw a triangle as your base. Draw a point that you're going to connect it all to, and then connect the vertices of the triangle to that point. And there's your triangular pyramid. You could make those lines hit dashed. Again, you can make these dashed to show that they are hidden behind there. But if you just want to draw it like that, that's okay too. That works. Okay, let's practice counting the faces, edges, and vertices of solids. Let me give you one that maybe we haven't done. Why don't you try counting the number of faces, edges, and vertices of this figure right here. So go ahead, pause, and count. You're trying to find the number of faces, edges, and vertices. Pause your video and count it. All right, so let's see. We are going to count the number of faces. So 1 in the front here, 2, 3, 4, 5 on top. 6, 7, 8, 9. You should get 9 faces on that. Okay, now let's count the number of edges. So trace, or you can go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you should have 16 edges. And then vertices, how many corners or points do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. There should be 9 vertices. Now this is a challenging one. These are especially challenging because like you don't have them on your paper where you can actually trace and point and color like we did on our other examples. So this one was a little bit more challenging to do. If you didn't get those answers, maybe you could pause the video and trace over and kind of try and recount and see if you can get that again. Let's try this one down here. Let's find the number of faces, edges, and vertices of this diamond here. Pause the video and get it. All right, so faces, you should have this one in the front, this one on the side, another triangle in the back, and another triangle on the other side. So that's 4 up top, and then the same 4 on bottom. So that's 8 faces. And then let's find the number of edges. So trace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. And then vertices, how many points? 1, 2, 3, 4, 5, 6 vertices. All right. Looking at this last example here, which figure does not belong with the other 3? So there are 4 figures here. Which figure does not belong with the other 3? Pause and answer. You should say this one, and the reason is these are all pyramids and this one is a prism. Okay, so hopefully you have thorough notes, you understand the lesson. Go ahead and you're going to submit your notes as a PDF and then complete the homework check. Mr. Chine and I will be on the Schoology conference if you have any questions. Thanks.